Hello, Pre-Algebra coming to you live with your second quiz here. This one, remember your formulas. Okay, looks like about half of it is based on circles, which was 13.3, and the other half is based on 13.4. So make sure you watch those videos first in order for this to make sense. Okay, so for the first two, we are finding the area of the figures below. We are using this for pi. Remember, area of a circle equals pi times our radius squared. So for this first one, is this our radius or our diameter? That's our diameter, so our radius is going to be what? 4 feet. Okay, I'll give it to you. 4 feet. Okay, plug that in to this formula. Give me the answer. Don't forget our area will have our units squared. Okay. Number two is tough. So I'm actually going to work it out with you guys. Okay, so this is a circle. So we're going to have to do the area of a circle plus the area of this rectangle. Okay, let's figure out the area of the rectangle first. The area of the rectangle, that's going to be super easy, is 4 times 2, 4 centimeters, times 2 centimeters, which is going to equal 8 centimeters squared. Right? Length times width, easy money. Okay, now, what, again, I need to do the, why don't I do my area of the circle up here so I have a little bit more space. So what's going to be, it's going to be pi times my radius squared. Well, pi, I'm going to use 3.14. But my radius, I'm going to use half of my diameter. I know my diameter is 4. Half of that is going to be 2. Okay, so that's still going to be 3.14 times 4. It happens to be 4, it just works out that way. Okay, and because I know you guys are all using your handy dandy calculator, 4, let's call that 12.56. So area of the circle is 12.56 centimeters squared. Plus 8 is going to be, so the area equals 20.56 centimeters squared. Okie dokie. Moving right along. The area of the shaded, so we're looking for the shade. So in this case, it's going to be the area, let's see, area of the square minus area of the circle. Okay, the square, let's see. Okay, so remember yesterday when I was talking about how the diameter of the circle, because it goes from edge to edge, the diameter of the circle will equal the side of the square. Diameter of circle equals side of square. Okay. So what's my diameter going to be? Well, I have, in this case, I'm given my radius. Our radius is half of the diameter. We know that. So my side is going to be 6 meters. 6 meters, okay? That should help you out. So my the area of the square is going to be 36 meters squared, right? I multiplied. Minus, I'll just give you the formula for this. 3.14 times 3 squared. Okay, yep, because I've got pi times my radius squared. So I'm just going to subtract, I'm going to have to square that, multiply that, subtract it from that, and that'll give me my answer. Okay, that should get you guys started at least. And here we had a similar one in our notes where we figure out the area of the smaller circle, area of, let's call it the big circle, minus area of small circle. Okay, that should be pretty straightforward. Now this one's, it's a little bit backwards, so I'll help you guys set it up. So the area is 153.9 feet squared. Well, we know that the area equals pi r squared. So if we have 153.9 equals 3.14 times radius squared. Now we need to solve for the radius. So this is just a variable that we're looking for, right? We're trying to find the radius. So what do? First we divide by pi. And then whatever that equals, so we'll have radius squared let's say it equals about 49, right? Because I've got 49.10, right? But you round to the nearest tenth, so that's what I'm doing there. How do I get rid of the squared? Tell me what the radius is, and don't forget your units. Okay. Okay, now what we're doing, this is from 13.4. Two similar polygons with a perimeter. So the perimeter ratio is 4 to 9. So remember, side 1 over side 2 equals perimeter 1 over perimeter 2. Now, in this case, because it's perimeter, we don't need to square anything, right? Perimeter, straight units, area, squared units, so that's where you square it. Write the ratio of lengths of their corresponding sides. Well, here's the ratio. Side 1 over side 2. What is the ratio of the area of... Oh, it goes from polygons to triangles. So for this one, I'll just answer it because this stuff is confusing. So number 6, the answer is side 1 over side 2. But what's the ratio of the areas? Remember with areas, so we would say if side 1 over side 2 equals perimeter 1 over perimeter 2, the area 1 over area 2 is going to equal side 1 over side 2 squared. Honestly, you guys could just put in these two as answers for 6 and 7, and I will give that full credit. Right, because those are just looking for formulas. They didn't actually give us numbers. Okay. Given that the perimeter of ABC is 14 inches. Oh, I should have just read the directions. So these two are similar. Number 8, given that the perimeter of ABC, so let's call this number 1 and this number 2. So I'm just going to start writing it out before I even finish reading it. So side 1 is 6. So again, side 1 over side 2, perimeter 1 over perimeter 2. My corresponding sides are AC and DF. So I've got 6 over 9, which equals perimeter 1 is 14. And perimeter 2, we don't know. We'll call that x. Well, I'm going to simplify this fraction here to 2/3 equals 14 over x, which is going to give me 2x equals 42. So my second perimeter is going to be I could call that x or perimeter 2. (21 inches). Now, number 9, given that the area, so again, side 1 over side 2 squared equals area 1 over area 2. So the area of this first one is 16. Find the area of DEF, we'll call that x again. Side 1, right, we had 6 and 9, but we established that we could simplify that ratio. So I'm going to do that. I'm kind of skipping that step of simplification. But this is going to be squared. 2 squared is 4. 3 squared is 9. So 4/9 equals 16 over x. Solve for x. And don't forget our units. Okay, number 10. What a doozy. Given that the area of the larger parallelogram is 108, so we'll call the larger one number 1 and the smaller one number 2. So area 1 over area 2 equals side 1 over side 2 squared. Okay, and area 1 it gives us is 108, so 108. And I'm looking for the area of the smaller one. We'll call that x. Now, it doesn't give us values for sides. So this is how it's got to work. Let's see. There's a couple different ways that we could go about this. But here's what I'm going to do. Is we can compare our side with the corresponding side. So we know it's a parallelogram, so this length equals that length, therefore this length equals that length. But I don't think we could find a value for A and B, so it's just going to be a fraction with variables. But I'm going to do the bottom one and the bottom one, which is this guy. So again, side 1, which is B, over side 2, which is B over 3. Now you might be thinking, what? How in the world do we do this? Well, don't be too frightened. When you have a division within a division, so a little fraction within a fraction, what you can do is this guy, and you guys are just going to have to trust me on this one, is going to come up to the top. So again, if this length is 1/3 that length, we could say this length is 3 times that length. So instead of calling it b over 3, I'm going to call this larger one 3b. And now I need to square it. Okay, so that's going to give me 108 over x equals, this is going to be 9b squared over b squared. Now this might look like some funny business, but what am I going to do with my variable? I'm going to simplify that. That gives me 108 over x equals 9. The ratio of the sides, of course, is going to be 9 over 1, or just 9, which is going to give me 108 equals 9x, which, which means that once we divide both sides by 9, x will equal 12. So the area of the smaller one will be area 2 will be 12 centimeters squared. Okay, guys, that was a lot of work. I hope it made sense. If you guys have questions, either save them for our Zoom chat tomorrow or feel free to email them. Otherwise, just know that I love you. Bye.